Good morning everyone, myself Yashashri and I am here to speak about something very important and which is very rare, like people much don't about know this. Welcome to an exploration of trigonometry's fascinating journey. We'll trace its origin from the practical geometry applications in ancient civilizations to its transformation into a cornerstone of modern analytic mathematics, which we use right now. Let's discover the brilliant minds who have contributed in this essential field. First, we have the geometry era, which is the ancient era. Hipparchus, a brilliant Greek astronomer, geographer, and mathematician, is widely celebrated as the founder of trigonometry. He is the one who is also known as the father of trigonometry. His main contribution was creation of the trigonometric table, the very first table. His primary motivation was to transform astronomy into predictive science by accurately calculating planetary positions. Some of more contributions were creation of chord table. He devised the first systematic trigonometric table based on the chord function, which measured the length of a line segment connecting 2 points on a circle. This table provided a lookup method for various angles within a fixed radius circle. The relationship between Hipparchus' chord and the modern sine function is given by the formula cot theta is equals to 2r into sine 2 theta. Standardization. Hipparchus popularized the division of a circle into 360 degrees, a system with Babylonian roots that remains in use globally today also. This chord table was the world's first lookup table for solving triangles, allowing astronomers to determine star and planet positions with unprecedented accuracy. Next we have Menelaus of Alexandria. Menelaus, another distinguished Greek mathematician and astronomer, significantly expanded trigonometry beyond its two-dimensional confines. He recognized that accurate astronomical calculations demanded working in spherical geometry, as both the Earth and the celestial bodies are spherical. His contributions were pioneering spherical geometry. His seminal work, Spherica, presented the first comprehensive treatise on the geometry of a sphere, laying the groundwork for understanding curved surfaces. Menelaus' theorem. He formulated a crucial theorem describing how a line intersects the sides of a triangle and more significantly extended this principle to spherical counterpart. Defining spherical triangles. Menelaus established the foundational principles for triangles. The sides are arcs of great circles, marking a monumental advancement from a version of Menelaus' theorem for spheres became a foundational part of spherical trigonometry, giving us important tools for astronomy and navigation. Claudius Ptolemy. Ptolemy, a Greco-Roman polymath based in Alexandria, produced a body of work that would dominate astronomical thought for over 1400 years. He was a master of synthesizing existing knowledge and refining it. His key contributions were refinement of chord tables. Building on Hipparchus' foundations, Ptolemy meticulously constructed more extensive and precise table of chords, providing values for angles in half-degree increments. Derivation of trigonometric identities. Utilizing his theorem in cyclic quadrilaterals, he was the first one to geometrically prove theorems equivalent to modern sum and difference formulas. Model formulas such as sin a plus b and cos a minus b, which we use in recent times also, which is being used in the world. Ptolemy advanced trigonometry was instrumental in developing his geocentric, that is earth-centered, model of the universe. Though his model was ultimately incorrect, its mathematical consistency and predictive power ensured its unchallenged authority of centuries. Aryabhatta made a big impact in math and astronomy. His main contribution was changing the way of solving problems with shapes. Instead of using geometry, he used equations and functions, that is algebra. Even though his methods differ from the modern trigonometry, it is very useful. Key contributions were shift from geometry to functions, as we saw it in the above topic. Second is defining sine and cosine. He was the first to explicitly time and work with the trigonometric functions of sine, which he named as Jya and Versine, Utkrama foundational to later developments. Creating sine tables. Aryabhatta constructed one of the world's earliest and most accurate sine tables, providing essential data for astronomical calculations. Aryabhatta's redefinition of trigonometric concepts as abstract functions rather than solely geometric lengths laid the groundwork for the analytical revolution that would follow. Sir Isaac Newton. Newton, an English physicist and mathematician, stands as one of history's most influential scientists. His co-invention of calculus fundamentally transformed trigonometry, shifting it from a study of triangles into a sophisticated branch of mathematical analysis. His contributions were infinite series. Newton made the revolutionary discovery that trigonometric functions could be expressed as infinite polynomial series. Sin x, where x minus x power 3 by 3 factorial plus x power 5 by 5 factorial minus x power 7 by 7 factorial, and this goes on. We can see the odd numbers here. In the same way, cos x is equals to 1 minus x square by 2 factorial plus x power 4 by 4 factorial minus x power 6 by 6 factorial, and this goes on, and we can observe the even numbers here. Application in physics. He extensively applied trigonometry in his seminal laws of motion and universal gravitation, using it to resolve forces into the vector components, which we are studying in our 11th class. The discovery was revolutionary, enabling the calculation of trigonometric values to any desired accuracy. Without relying on tables, it redefined sine and cosine as universal functions amenable to the powerful new tools of calculus. Leonhard Euler, a Swiss mathematician, is celebrated as the most prolific mathematician in the history. His profound work impacted every field of mathematics, providing trigonometry with its modern language and unified framework. His key contributions were standardization of notation. He introduced and popularized the standard notations we use today, which includes sine, cos, tan, and fundamental constants e, I, and pi. Euler's formula, e to the power ix is equals to cos x plus I sin x, e, where here e is the Euler's number, that is, which is a constant approximately 2.718, and I is iota, as we know, imaginary number. Often hailed as one of the most beautiful equations in mathematics. It has created a magical bridge connecting trigonometry to exponential functions and the realm of complex numbers. Euler's identity, x is equals to pi, gives e to the power I pi plus 1 is equals to 0. A special elegant case of his formula that stunningly relates the 5 most fundamental constant in mathematics in a single statement. Euler solidified the modern definition of trigonometric functions as ratios within a unit circle, which remains the primary definition taught and used today, even in schools. Conclusion. The enduring legacy of trigonometry. From geometry to analysis, the ancients such as we saw, Hipparchus, Menelaus, and Ptolemy crafted trigonometry as a geometric tool for practical problems like mapping stars and Earth. Reimagined for modern science, the moderns, that was Newton and Euler, reimagined it as an analytical system of infinite functions, linking it to calculus and complex numbers, which is also used in our physics. Bedrock of STEM. We have learned about STEM in our regular life too. The combined work of these figures underpins nearly every STEM field: physics, biomechanics, signal processing, computer graphics, and beyond that. Applications of trigonometry are vast. Journey of mathematics. Trigonometry's story mirrors the journey of mathematics itself, from practical problem solving to abstract powerful theories. The enduring legacy of trigonometry, forged by centuries of brilliant minds, continues to shape our understanding of the universe and power technological innovation. In conclusion, I would like to thank my friends and our respected teacher for giving me this opportunity.